This video is on systems of linear inequalities. Okay, so what does the graph of this system consist of? How would we go about solving this? First, you should know how to graph a linear inequality. So I have an example for you. This is the graph of y is greater than 4x plus 1. The first thing you do is you plot the line y equals 4x plus 1. And as we know, we have a slope of rise is 4 over run is 1, and y-intercept of positive 1. So you can see the y-intercept there, right? And you can find the x-intercept by saying when x is, or when y is 0, what's y? Well, we'll get negative 1/4. So you'll plot that, and you can draw the line through it. So now what about y is greater than 4x plus 1? Well, so this computer program shaded in this side right away for me, right? I didn't have to do anything. But how does it know? Well, we can test a point x and a y and shade in what makes this true. That's essentially, we're looking for all the points that make this inequality true. So we can see that 0, 0 will not make this inequality true, and that's an easy point to test. So we do 0 here. Let me pull up an equation editor. So we have y is strictly greater than 4x plus 1. Let's try the point 0, 0. So you get 0 for 4 times x, and you get 0 for y. So, and then you get 0 is greater than 0 plus 1. So is that true? Of course not. 0 is not greater than positive 1. 0 is greater than negative 1, but not positive 1. Okay, so you can see that this point makes the inequality false, and hence it is then everything on the other side of the line would be shaded, and that's how you do it. Okay, so what about two inequalities? Well, let's try y is greater than negative 3x plus 1, right? So we can see that this one, it has a different shading, and this is the area that they're both shaded on, right? So we can get rid of this red one for a sec. You can see just the blue one. So this is the region they share. And that's kind of what we'll be doing in the problem we're working on today. So we have this. So we have two lines and they graph them for us. Now think about this for yourself for 1 second. Which one is y strictly, or is less than or equal to 2x? Well, we don't see, there's the y-intercept is 0, so it should be going through 0. And it's a positive slope, so it should be going like this. So this is our line. We can clearly see that. And then on the other line, y is less than negative 1/2 minus 3. Well, we can clearly see that negative 3 is the y-intercept, and it's a negative slope, so it's going this way. So we know which one's which. And so it's asking which regions this consists of. And let me pull my graph up again real quick, and just to show you. So you see the computer also did dotted lines for us, and if we wanted less than or equal to, it would change it to a solid line, right? So the solid line is inclusive with the less than or equal, and the dotted line is strictly. So so this one includes this line. Oh, sorry, I misspoke. We agreed that y less than or equal to 2x is this line. So we know that this inclusive is including L2. And when we see part of L2 and part of L2, that's what we're going to be looking for. So we already know we can get rid of, and furthermore, y strictly less than this, we know we won't be including part of L1 because it's not less than or equal to, so we can get rid of this. And we know we'll want to include C and part of L2, or B and part of L2, so we'll get rid of B only and C only. So we're really looking at just these two solutions. So now let's figure out which one. Now we're going to be testing the lines, and again, my favorite point to test is 0, 0, except this isn't a good point because we have a line running right through 0, 0. So we're going to want to test a point like negative 5, 5, like right there, or 5, 0, like right here. So let's first test with this first line, L2, right? So we're either looking for the B only or C only. So let's see what we get. So if we test the point, x is 5, y is 0 for this. Let's test the point x is 5, y is 0. So plug in x is 5 and y is 0. Well, you can clearly see that that's true because 10 is going to be greater than 0 or equal to 0. So we know this whole area is true, right? And then this line is going to determine whether it's B or C. So if we're going to shade in below the line, it's going to be C. If we're going to shade in above the line, it's B. Because we already said this CB region is what we're looking for. But again, there's two answers, C or B. So that doesn't definitively tell us. So let's look at the other one. But we can test the same point in the other one actually because it's over here. So we're testing for B now. So here's the other equation. So we said x is 5 and y is 0. So what do we get? Well, we get negative 5 halves. That's negative 2.5 minus 3. So that's negative 5.5. Is negative 5.5 greater than 0? I don't think so. A positive number is greater than 0. So this is false. So we're saying this region above this line, which includes that point, is all false. So A and B are both false. So we know it's going to be C because from this line, we said it's somewhere below this line, so it's B and C. And we said it's somewhere below this line, so it just leaves us with C. And that's the correct answer, C and part of L2.